In this video, we are going to talk about uncertainty in measurements. So, a measurement can be accurate, precise, and both of them, which means, so let's say accurate is A and precise is P. Both, it means accurate and precise, or neither accurate nor precise, or inaccurate and imprecise. So when we carry out a set of measurements, the measurements that we obtain are either accurate, precise, or both, which means accurate and precise, or neither, which means imprecise and inaccurate. So let's suppose that we have a sample of gold. We have a sample of gold. Here we have a gold. And this sample of gold, it has a given mass. A mass that is known mass, that we call the true value. And we'll use three different balances. We'll use balance 1, that is balance 2, and balance 3. So we'll measure the mass of this gold with each balance. Of course, the three balances are of different characteristics, okay? And with each balance, we'll measure the sample 5 times. So we'll have here 5 value or 5 masses. So we'll have a first mass, a second mass, the third mass, fourth mass, and the fifth mass. So with each balance, we'll have 5 values or 5 masses. And of course, we'll compare between each balance. So we'll evaluate the set of measurements. Here we have a set of measurements. So each set of measurements will be evaluated in terms of accuracy, precision, and we'll see if they are both accurate or precise. And as we carried out these 5 measurements on each balance, we got results. And these results will be compared to the true value. Okay? So, for the sake of simplicity, we'll show the results as marks on archery targets. So, like here. So we have here the 3 balance, and we have used an archery target. And the 5 measurements, the set of measurements are shown as marks. Here, with the first balance, we have the 5 measurements. And the center here, it is supposed to be the center here. It represents the true value. The true value of the gold sample. So here we observe that the set of measurements are stuck together, which means that the balance 1 gave a precise measurement. Besides, the 5 measurements are very close to this center, which represents the true value, which means that the first balance gave also an accurate result. So here we have a precise and accurate measurements. With the second balance, we can notice easily that the 5 measurements are stuck together. They are very, very close to each other, which means that the balance 2 gave a precise result. But when we compare the distance between each result or each mass and the true value, we can observe that there is an important distance between each value, which means that the set of measurements is not accurate. So here we have a precise measurements but not accurate. With the third balance, we can notice that each value is far from the other value. So here we can notice easily that the balance tree gave an imprecise result. Or not precise. And if we do evaluate the accuracy, we can also notice easily that the distance between each value and the true value is also not close. So here we have measurements that is not accurate or inaccurate results. So let's write here not accurate. So the third balance gave, let's say, the list or the third balance. With the third balance we have imprecise, not accurate results. We can also add another types of evaluation. For example, we could have had an accurate result but imprecise. For example, if we draw the archery targets here, for example, here the true value. If, for example, we had this marks here, for example, here the center is the true value. If we, for example, we have this first, second, third, fourth, and 5. Here we can notice that the 5 measurements are close to the true value, which means that the values are accurate. Here we can say we have an accurate set of measurements, but the distance between each value is not close. So we have here an imprecise measurements. Here let's say that is imprecise.